All right, guys. Today we're going to talk about the quadratic formula, a pretty important piece of mathematics, as the this idea ended up leading to the discovery of other mathematical concepts. And originally, this idea was discovered by, or this equation was discovered by a Indian mathematician in the third century, whose name I'm not even going to attempt to pronounce. But eventually it would be added upon by others and discovered by Rene Descartes in the Renaissance, and when it really became something that was used in Western and European mathematics. But essentially, the idea is hyper, or the idea is important when dealing with graphs of functions like the one we see right here. And in this function, we can identify some key parts of this pretty easily, right? I mean, I got my y-intercept right here, right? Y-intercept, and that's going to be at 0, 7. I've got my vertex right here, right? My vertex is going to be at 3, -2, right? My line of symmetry, again, going right through that vertex, right? Coming on down here like so, at x equals 3, right? So there's a lot of things that I can do with this. However, one of the things that I can't do based off of this graph is identify what my x-intercepts are. I mean, I can look at it and I can say, okay, I've got some value between 1 and 2 right here, and over here I've got some value between 4 and 5, but I don't know exactly what those are, and I might even be able to try and guesstimate it or round it as best as possible. But is there a way to calculate the exact value of those x-intercepts? And there is, and the answer, or the way to do that, is through this quadratic formula. Quadratic formula, for those of you guys who remember, is going to be defined as -b plus or minus the square root of b squared minus 4ac, right? All divided by 2a. And for those of you who are confused about those symbols, there's the a, b, and c, the variables. What do they represent? This is all relating to our standard form of a quadratic function, which was y equals ax squared plus bx plus c. And so if we have the standard form of this function, we should, in theory, be able to calculate those x-intercepts using the quadratic formula, this nifty piece of mathematics right there. And again, this discovery led on to the discovery of other mathematical concepts, which we'll talk about in the next video. But for now, let's talk about what this video is, or what this is going to be, or how to calculate those using this formula. And you know what? Just for the sake of review, let's go ahead and come up with the equation of this function on our own. And we can do, I think the easiest way to do that would be through vertex form, right? So let's plug this into vertex form. If you guys remember, vertex form is the y equals a times x minus b squared plus c, where my b value is the x value of my vertex. In this case, that would be 3. And my c value is the y value of the vertex, and in this case it would be -2. So we could write that out as y equals a times x minus my b value, which is 3, squared, and then plus c, which is -2. So plus -2, or in other words, subtract 2. Last piece I just need to figure out is my a value, and I can do that a couple of different ways, but the easiest is probably by plugging in a point, right? Plugging in a point into this equation. And for just remember that when you're plugging in these points, depending on the form that you're in, you don't want to use the point that references the form. So if you're in factored form, you don't want to use the x-intercepts. If you're in vertex form, you don't want to use the vertex. But I can see this y-intercept that seems like a pretty easy one to use, 0 and 7. Let's just plug that in for our various values there and solve for a. So in place of my x value, I put a 0 in place of my y value, I put 7. So I've got 7 in place of y equals a times 0 instead of x minus 3 squared minus 2. Well, 0 minus 3 is just negative 3. Negative 3 squared is going to be positive 9, right? Positive 9. So we can rewrite this now as 7 equals 9 times a, or in other words, 9a minus 2. And now I just want to get all my numbers on one side and solve for a. So let's start by getting rid of that 2. We gotta do the opposite of what's being done. We're subtracting, so let's add 2 to both sides, plus 2 to both sides. Those cancel out. And then I would get 9, or 7 plus 2 is 9, equals 9a. And I think that most of you have realized what the a value is here. But if I divide by 9 to get rid of that times by 9 on both sides, I get a equals 1. And in that case, since we're multiplying, remember, I don't even need to include that because, 1 times any number is just that number. So my equation then for this is going to be y equals x minus 3 squared minus 2. Okay, but important to remember here, guys, that we want this in standard form. So we need to distribute out this x minus 3 squared, combine like terms, and simplify to get it into standard form. So a little bit of work, but I thought this would be a good review for you guys as we go through this. So I would get, let's rewrite this now as y equals x minus 3 times x minus 3. That's the same thing as squared, right? And then minus 2. We can use our FOIL method, the first times the first, which is x squared, and then the outside, which is x times negative 3, which gives us negative 3x, and then the inside, which is going to give us negative 3 times x, which is negative 3x, and then the last, which is negative 3 times negative 3, which is positive 9, and then we can't forget to subtract our 2. And simplifying this, I would get, let's write that up here so we can have it in our standard form here, y equals just 1x squared, right? And then I'm going to have negative 3x minus 3x, which is negative 6x, right? And then 9 minus 2, which is positive 7. Okay, and so now that we have all of our parts, we can identify these. My a value is going to, my a value would be, this is really 1x squared, so I've got my 1. My b value is this negative 6 right there, right? So I got negative 6, and then my c value is this positive 7, right? So I've got all my parts. We just got to plug this into our equation and then just simplify, and that should give us our x-intercepts here. So it's negative b, which is negative 6. So I've got a negative 6 plus or minus the square root of negative 6 squared minus 4 times a, which was 1, and c, which is 7, right? And that's all divided by 2 times 1. Well, we can start simplifying this pretty easily and pretty quickly. Let's start with inside this piece right here, and just for the sake of making this a little more readable, let's switch colors here. And so negative 6 squared is going to be 36, and then negative 4 times 7 is minus 28, right? Hope that's visible enough. I don't think that really is. So let's rewrite this real quick. So I would get, and this negative 6, we can change a negative and 2 negatives make it positive, right? So I would actually have 6 plus or minus the square root of 36 minus 28, all divided by 2 times 1, which, you know, we don't even need to put that 2 times 1 because that's just 2, right? So let's simplify inside here. My 36 minus 28 is going to give me, 36 minus 28 is going to give me 8 on the inside here. And if you guys remember from our previous video, you should be able to actually do the square root of 8 pretty easily, right? So I'm going to get 6 plus or minus the square root of 8, which is all that's left inside that radical there, all divided by 2 on the bottom. And we've got this. This is a lot more manageable piece of information here, and we're almost finished, guys. So let's just go ahead and go the rest of the way. Can we simplify that square root of 8? And if you remember for your radical video, guys, we can come up with the factors of this, right? And the factors of 8 are going to be 2 and 4, and then 2 and 2. And since I'm taking the square root, I want sets with 2 in them, right? With 2 numbers in them. So I got 1 there, and then I got my remainder here. So this is going to simplify. Let's rewrite this. I'm going to get 6 plus or minus 2 from my what I pull on the outside, and then my remainder on the inside, which is my 2 right there. 2 square root of 2, all divided by 2. Well, fortunately for this, I can actually divide 2 out of both of these pieces, right? Well, what is 6 divided by 2? That's 3. And what is 2 square root of 2 divided by 2? That one might seem a little more complicated to you guys, but let's just think about it this way. If I take 2 square root of 2 like this, go like that and write it as a fraction, what happens to these? Well, those just cancel out, and I'm left with the square root of 2, right? So I'm going to have 3 plus or minus the square root of 2 as my solution. And I don't need to go any further. I don't need to go any further. That's everything that I need for this. But if we wanted to, we could, you know, just to verify our solutions here, we could take the square root of 2. And the square root of 2 is going to give us roughly 1.4, right? So we have roughly 1.4. I've got, if I take my, you know, 3 plus 1.4 is going to give me about 4.4 approximately. Let's make that a nice little approximate thing there. And if it's 3 minus 1.4, that's going to give me 1.6. And is that about what we got here? Yeah, that looks about like a 1.6 and a 4.4 right there. So this does work. And the best part is I can write this now as a radical number, and doing that, whereas, you know, doing that allows me to, sorry, as an irrational number, allows me to give the exact solution, right? These ones right here, I mean, those are just approximations, right? I had to round those, but this is the exact solution there, and it becomes pretty easy to express this answer with certainty using those radicals. Okay, hopefully that quadratic formula made sense to you guys. But as always, if you have any questions, let me know, guys. But the important thing here, just to identify, just like we did at the start here, I've got to identify my A, B, and C values, and then plug those into my equation here. Yeah, you're going to have a little bit of algebra that you're going to have to muscle through, but it's not too bad. Okay. Again, if you have questions, let me know. Otherwise, guys, I will see you in class. Thanks.